Hello. Yeah, it's it's been a while since I did this. It's with everything that has been happening, namely the World Cup. Um, I am I have not been the best at keeping up with the learning sessions that I was planning to do, or that I said I want to do more. Right, but I do want to get back into it. It's been about like what, a week and a half, or maybe 2 weeks since the last one. But yeah, but I'm back again. This one should be a short one. It's not exactly the live learning kind of session. It is still live learning, but it's not live learning of the tensotonic or like AI kind of thing. I have a company called Rerun.io, and they are producing. Um, they have this open source SDK that I want to kind of learn and understand more carefully. And I want to thought like, okay, let me just take the time to do that live, so that future me's or future generations can use it. All right, let me share my screen to show you what is the company that I'm referring to. It is this one. All right, so I mean, as we know, right, like physical AI, the kind of embodied AI or like robotics, becoming increasingly huge category for startups, as well as, I guess, general forms of research and products. And for physical AI, um, just as humans, they have a ton of different sensors and the type of data that comes, right? Like, and namely, it's like multimodal data. So it can be audio data, sensor data, pressure data, like vision data, or like image data. And yeah, and by correspondence, like video data, and even like sound data, right? Like, so we uh, physical AI needs a way to understand all of these multimodal data. And the other thing is, they also need a way to understand these data that occurs with different frequencies, right? For example, the sensor that senses the joint movements of a robot need not be of the same kind of frequency or like same rate as the vision data that would be happening like so much at a much higher rate than, I guess, like the, as I said, the joint data. And similarly with any other kind of like multimodal data, any other kind of like source of data. So what the physical AI need is a way to like quickly streamline the collection, and yeah, the collection of all these multimodal and multi-rate data, so that it makes the model easier to understand. It makes these data easier for the AI to be trained on, and stuff like that. And this company, Rerun.io, is emerging as a way to visualize these multimodal data and multi-rate data on the single place, and have a data form and a data structure such that you can easily, or at least the engineers can easily query and transform it, and log store and convert, and make it easy for you. Make it easy for them to use. What to say? Especially like to train the model over, right? Like, so you can see their, I guess, propositions, which is they're making the infrastructure that powers the data loop. So you can query your recordings with SQL. You can refine your data without copies. You can train without an export step. Everyone works from the same data. And they have some blogs. I haven't read the blogs, so I might read them up in the later on a later video. But basically, I wanted to take this time to, oh yeah, so this is one of the blogs that I was planning to get myself into, but let's see. Basically, I wanted to, oh, that's not the blog then. Basically, I wanted to see quick start guide, and they have the open source. Oh, that's Discord. They have their code base here that I will just clone. Let's see. Yeah, I'm just cloning the GitHub locally. Let's see. So what did it say? Log rerun, or at least this is the data layer of physical AI. It allows you to log, query, visualize, and stream to training on shared columnar structure built for multimodal data. What it does, rerun ingest multimodal, multi-rate, multimodal data, images, point clouds, transforms, time series, joint states from many sources and formats, such as robot logs, human data rigs, SIM, web video, MCAP, RRD, Lee robot. Full stop. The built-in viewer renders everything in sync in real time, scrubs. It renders everything in sync in real time, scrubs episodes, compares sensors side by side, watch CV pipelines run live. The same data is queryable with data frames or SQL and streams directly into training. Built in Rust on column chunk storage, purpose built for multi-rate physical data. SDKs in Python, Rust, and C++. I could do the quick start. Right. The other thing that I think would be interesting to have is Matt Pocock. Skills teach, was it? No. I want to use that to teach myself rerun. Let's see. Everything is there. My background, everything is there. All right. And the next thing that I want is, let's get started, right? Use with LLM, copy with, and the AI agent that I want to use is, let's see, Codex. Make directory rerun. And sorry, I'm I'm trying to set things up in the background so that I can have an easier way. So that I can have an easier way to like understand the thing. Okay. All right, let's share my screen then. Well. All right. Some references. Rerun.io. Rerun code base. All right. I'm really can't see it that well. Sorry. So yeah, I wanted to. I love Codex, and I thought to use it to teach me. And some of the references that I gave was the company website, the quick starting website. I didn't. I could have copied and pasted um, the long-term docs and like just pasted it here. But let's see if it is able to do something on its own. I gave it the code base uh, that I cloned. I also gave. Um, let's see if it can see it. Uh, Yeah, I gave it. I asked my Hermes agent to just scan the repo and summarize or draft up a report on what it thought, um, what what it thought the GitHub was and like what it projects was. So you can see it here, and I also asked it to like draft up some weekend projects that you can like hack from their code base. I haven't like fully hacked it. And given that I personally don't haven't been through the code base, I don't know how much of this is like relevant versus how much then it like the agent is just being too eager to suggest things. But let's see. Let's see what it is trying to do. I use the T-scale. I give it a bit of cutback model rather than. Well, this is running in the background. Let me just stop sharing and then just. Well, let's read what it is trying to do. Rerun helps robotics and physical AI teams iterate faster. Local minutes, okay, you can have the installation and then set up a project, which probably is going to be all right. And then open the viewer, which is we can pass a file directly to open a viewer, but scale across many recordings. Well, start catalog server. Ingest. All right, point the viewer at your server. You can also train it. All right, next reference. Okay, started. Let's just read this. It covers the whole journey from raw recordings to. Sorry, for some reason it appears a lot smaller on your screen than it does for me. Rerun covers the whole journey from raw recordings to training on a single unified data layer for multi-rate, multimodal robotics data. It's comprised of Rerun SDK, an open source library and tools for logging, storing, queuing, visualization, and training on multi-rate, multimodal data. And then Rerun Hub, a data catalog and backend for large-scale storage, access and streaming of robotics data from object storage. The problem: building intelligent physical system requires rapid iterations on both data and models, but teams often get stuck because data from sensors arrive at different rates and in different formats. Yep. Understanding what went wrong requires visualizing multimodal data together in time, extracting clean and preparing data for training involves too many steps. Switching between different tools for each step slows everything down. The best robotics team minimize their time from new data to training. Rerun gives you the unified infrastructure to make that happen. Who is Rerun for? Rerun is built for teams developing intelligent physical systems, robotics engineers, perception teams, ML engineers, autonomy. How do you use it? Log and ingest. So you use the logging API to log multimodal data, or the chunk processing API to convert your existing data to the RRD format. And this is the custom bespoke file format that they use as a way to convert all of these multimodal, multi-rate data into a more into a file format that is like more conducive to solve the problem, right? Like that they have set up. Where it's down here. Query and transform. You can also use, let me just have a mental model while we are having that. Okay. Well, let me just go back to Codex and see what it has built. All right. Built. So what's the reason? And we run well enough to recognize Borussia Windows more useful as pilot demo about decks or the time of the one is not full based code based bound for area successful very well okay. Right. Sounds good enough. Resources. Okay. Let's see. Okay. Lesson 0001. After this lesson, you should be able to look at a rerun example and name the entities, timelines, archetypes, and likely viewer surfaces. Rerun center of gravity is not draw me a chart. It is record a changing system, so I can scrub, inspect, query, and reuse what happened. The 8020 shape, so you can log, emit rich system state from code, organize, name things with entity path, parts, time, attach each log to a timeline, view, inspect the recording visually, reuse, save, query, transform, or train. The official docs describe Rerun as a tool for logging, querying, visualization, and visualizing and streaming multimodal data on shared columnar storage. The local repo architecture says the SDK encodes logs with Apache Arrow, which is something. Sorry. Okay, SM saves them as .rd in the viewer. Okay. Yeah, the 4 words to recognize: entity, archetype, timeline, and recording. So entity is a name thing in the recording, like camera, font, or agent, messages. Think, where does this live, right? Like, so what probably mainly what is this, what does this data mean, right? A ready-made, so archetype is a ready-made shape Rerun knows how to log and display, like text log, scalars, image, or points 3D. Timeline, the access for scrubbing and alignment, such as step, frame, or sensor time. The recording. This, okay, so I can't see this very well. Rerun came from robotics, where camera frames. So let me see if I can see if yeah. Import Rerun as rr.init. agent trace save agent trace.rrd for steps, comma event, and enumerate events. Set time step sequence equals to step rr.log. All right, just reload this. Didn't do what I wanted it to do, but all the same. Yeah, rerun comes from robotics and computer vision, where camera frames, poses, point clouds, predictions, and metrics happen all at different space. Retrieval check. All right. What's the question is in rr.log agent/latency ms, rr scalars. What is the agent latency ms? It is probably, it looks like an entity path. Sorry, entity path. All right, the next move it suggests is open a reference sheet and inspect the tiny agent trace demo, which is where. So you have log. You can use Python, Rust, C++ importers or file to image rich data. You can organize, such as the entity tree, pull data onto entity parts like you can time views, etc. If normal logging is directly in the time machine for structured visual fate system. Core vocabulary, entity, what to ask of any, what are the entities, what are the timelines, which archetypes fit, what view should appear, what survives the demo. Save RRD, create or stream result. Okay, let me just look at this. This is just a Python script. Set up this directory as a repo and let's see what it's trying to do. Events message. Also, it is trying to write it in a custom manner. While we wait for this to finish, let's continue reading. Continue reading this. Where were we? Yeah, so we were here. How do you, there's a logging API, which it's not, let's black box it. So it's an API that logs that you can use multimodal data from your code, or the chunk processing API, which presumably is a different API to convert your existing file to the RRD file. All right, so what it looks like, you have the existing data, which can be MCAT, LeRobot, etc., and then you use a converter or a data generator to generate the file format, like the data format that Rerun has created, .rrd. The other use case is to visualize. So Rerun built an open source pre-built viewer that is adjustable and extensible. You can log directly to the viewer and open a range of file formats to get data into the viewer, or even connect the viewer to a Rerun catalog. What does it mean? Catalog. Stored in a given catalog. Okay, that's fairly interesting. Then you have query and transform. You can use the open source. You can prepare catalogs. So catalog does seem to be an important repeating word or entity or a noun. Or automated importers. So you need to Rerun viewer. Okay. Catalog. Okay. Here. We refer to the content store in a given catalog server as the catalog. The catalog contains top-level objects called entries. There are currently two types of entries, tables and datasets. Each is described in more detail below. Entries share a few common properties: ID, name. Okay. With datasets. Interesting. Layers are immutable and can only be all written by registering a new .rrd file. Schema. All right, let's just do a quick start then. Okay, let's all right. So it did this. Okay, let's see. Interesting. So this is what the Run Hub looks like. Let me show you the server. Where is it? This is what it looks like. Oh, viewer. Right, and this is the fake data that Codex created, right? So you have these entities, which are generally messages, but they come at different latencies, or they have been configured with different latencies, right? So you have the latency of what does it look like? You have the latency of yeah, tokens for 2 for 2. I'm not sure how to read this one, but it probably means something like the first entry, just this, has a latency of 780. Let me just stop guessing and take a look at the pseudocode. Not the pseudocode, but the dummy code. And so you have events that you're trying to log and save as rerun. The events, the thing is, the events can be from different places, right? So you have, this is trying to simulate an agent log. So you have a message where a user asks for a rerun 8020 lesson. The level is at info. Latency is 120. Tokens is 84. Then you have another message, agent inspects, agent writes, and they are all happening at different latencies. Okay, so this is okay. How to Yeah, think of the rerun recording as a small time machine for one fake agent run. Sorry, one fake agent run. We created 4 fake events. Each event that becomes a rerun recording with one timeline step. Yes, each loop iteration does this. rr.step. So rerun sees step 0, step 1, step 2. The meaning is agent message attack log of what the fake agent did. Okay. So when you scrub the step timeline in the view, you are moving through the agent's rerun lines up the text and numeric values by the same time index. The dummy data is intentionally simple. It's not real telemetry, and it's a toy version of what a real agent trace might look like. Right? So you have a real user message, which can be a text log. You have the assistant reasoning event, which is a text log. You have latency, which are scalar numbers. You have token usage, which are scalars. You can have browser screenshot, which is images. So the demo is teaching the basic rerun grammar. What happened? Where does it live? When did it happen? Okay. So currently, okay. So should I ask you questions about the rerun? No, that is making individual agent. Okay, so introduce multi-rate data, give messages but add latency token samples is one of the changes why we access and one margin dollar. Okay, so my recommendation is ask me to upgrade the demo so the most users so may ask me to upgrade the most make the current. Okay, sure. Make the current demo more realistic with messages and then explain how to read the recording for the sake of historical let me say for the sake of tracking okay while it is I'll just cancel this. Wow, just a bit. Alright, let me stop sharing this and let's go back to reading more about Rerun. Okay. So let's try to understand what this is trying. What is the you import a math? You import Rerun as RR with RR.recording stream, which is Rerun example getting started. Recording ID equals to run1. Send properties equals to fall as rec. So you open a particular example as a recording object, as a rec object, or recording stream object rather. And then you save it or you initialize it as the .rrd file. And then you start to write into the .rrd file, which is for t in range of time, for t in range of step t, rec.step set time equals to step equals to sequence equals to t. Rec.load arm shoulder. Okay. So now that's interesting. All right. Okay, let's go more into references. Types. Rerun has 3 levels of types that can be used in. Okay, it seems like codex is done. And this is what the rerun looks like. So you can see so let's see. So you have a few different entities. You have the agent, but then you have events. And event is something like, can you set up this folder? Can you set up this folder as a learning repo assistant? Can plan. Okay, events are. That's interesting. So you have the input tokens, the metrics, the output tokens, you have the live tokens, the tokens per second, cumulative tokens. The thing is, I still don't fully understand what I'm trying to get out of this. Let me all right. I have asked Codex to create second lesson, so this is what we have. All right. Let's say the Rerun viewer is a recording browser, not a finished dashboard. The viewer answers three questions: what entities were logged, what shape each entity has, and how those entities line up over time. So your entity tree, where your log things live, and this demo most part starts with agent. You have agent, agent tools, all agent tools, messages, and such things like that. At least for the demo that we had, and then you have viewport, the actual views, text, logs, plots, graph views, selection slash details, and then you have the time panel, which is the scrubber. And what this demo is trying to show, the recording is a toy agent run. It's not meant to be impressive yet. It's meant to show how several different signals can belong to the same run. Agents eval. Oh, maybe I should have read the code. So yeah. Step 2, message initialize get data. Normal log flattens, terminal log how to inspect a recording. What is missing from the tab? From the examples, what do you think is fine? Yeah, let's see. Right. So the Rerun repo has some examples of drone LiDAR, new scenes datasets, IMO signals, detect and track objects, animated URDF, live depth sensor, and D-robot. It looks like they are all of the same. Okay. It's cool, but it teaches model pipeline plus rerun rather than rerun itself. The next concrete data is text, so will make it make good. Sounds good. Sounds good. Sounds good. Okay. Right, let me stop sharing and just look at the code base myself. So let's see. So you have example use cases. Here you're building a vacuum cleaning robot and it keeps running into walls. Why is it doing that? You need some tool to debug it, but a normal debugger isn't going to be helpful. Similarly, just logging text won't be very helpful either. The robot may log going through a doorway, but that won't explain why it thinks the wall is a door. What you need is a visual and temporal debugger that can log all the different representations of the world the robot holds in its little head, such as the RGB camera feed, depth images, LiDAR scan, segmentation image, how the robot interprets what it sees, its 3D map of the apartment, all the objects the robot has detected or thinks it has detected as 3D shapes in the 3D map, its confidence in its predictions, etc. You also want to see how all of these streams of data evolve over time, so you can go back and pinpoint exactly what went wrong, when, and why. Maybe it turns out that a glare from the sun hit one of the sensors the wrong way, confusing the segmentation network leading. But seeing the world from the point of view is not just for debate, it also gives you nice about how to improve the algorithm while seeing another. Okay. Rerun versus orbits. What pure visualization you might need. You might be used to seeing the latest data only. Rerun is more than a pure visualization tool. Yeah. In robotics, you can use rerun example to record test runs, manage and curate training data, visually debug live streams or recordings. So while rerun makes your data streams visualizable in the viewer, integrating rerun logging into your robotics applications also opens up the door for leveraging rerun's broader capabilities. If you're only interested in visualization, the rerun viewer has powerful features like the ability to go back in time thanks to its time-aware in-memory database. You can adjust the size of this buffer to your needs. Right, business model. All right, so wait, other examples. Not this one. Check that. Can I do this? Right here. The rendered example that we did the adding a new ones to display the main manifest. Let's see, in Python we have what was the structure for motion, is it? Structure for motion. Right, visualize a sparse reconstruction of core map. Sparse model of central run. A general purpose structure for motion and multi-view stereo pipeline with graphical and command line interface. And so you have the image, and you have the spatial, and then you have the plot of what's happening. Core map is a general purpose structure for motion and multi-view stereo pipeline. In this example, a short video clip has been processed offline using the core map pipeline. The processed data was then visualized using a rerun, which allowed for the visualization of individual camera frames, estimation of camera poses, and the creation of point clouds over time. When using core map in combination with rerun, a highly detailed reconstruction of the scene. The images are logged through the image to the camera image entity. The images stem from pinhole cameras located in the 3D world. To visualize the images in 3D, the pinhole projection has been logged and the camera pose is often referred to the intrinsics and the intrusives. Oh, that's very interesting. So you have a reprojection error for each image. A scaleless archetype containing the average reprojection error of the key points is logged. Run this code. CD run and get out, check out later. I'll do a little experiment. All right, let's see. Structure for motion, read model, read write model pi. So what is it doing? You have a camera model. So this is basically reading and writing the camera files. And yeah, input output description is possible to the component like doing an examples core map. Okay. All right. Good times. Now let me go back to Codex because it has stopped at work. So let's see. So what for? Let's try to understand. Rerun turns structure for motion into an inspectable process. Goal: understand how rerun enables more than a recording for the local core map structure for motion demo. Structure for motion turns many 2D photos into camera poses plus sparse 3D points. Rerun lets you inspect that transformation as linked visual evidence over time. So the whole workflow looks like this. You have the input where you have many 2D images of one scene, and then you have features, which are 2D key points found in each image. And then you have the geometry, core map, estimated camera poses, and 3D points. And then you have the quality, which is a reprojection error, says how well 3D points explain 2D evidence. And then you have rerun, which where you have the images, poses, points, key point, and an error becomes one synchronized recording. What rerun adds, it connects 2D and 3D now. The viewer can show the camera image and the 3D reconstruction error. 3D reconstruction together. This helps you see how a flat image contributes to a spatial model that makes times blah, blah, blah. And the entities in this recording are description, camera image key points, and then you have how big idea. rerun is useful because structure for motion is not one artifact. It's a relationship between images, detected features, estimated camera motion, 3D geometry, and error. Let's see. So let me just take a look at the code for a while. Should be kind of similar to the one in GitHub. So basically have the data, then you have the recordings, which is the .rrd file that you have converted to, oh yeah, you have the recordings directory where you will be creating this .rrd file into. So let's see, description. So you create the blueprint first. All right. So this is how the rerun looks like. The local structures, and this is the blueprint, right? Like, so you have the vertical container. Within that, you have the 3D construction, you have the root, you have the cameras, you have this image, and these are the 2D key points. These are the key points. Yeah, 2D feature observations in that frame. So you have these key points and then some other points. Which I want. You need the horizontal container, which is what is this recording for, what is the camera frames and key points. Okay, I can see the projection error. And so let me just So let's see, you have the camera and the image is moving, as we see here. And then you see how the key points are being translated. Yeah. The temporal translations are being recorded, 30 times? Logged 30 times, yeah. Quaternions are base, I think, describe rotation, right? And then, yeah, relation temporal transform 3D relation log 30 times, log 30 times, and image is also logged with. For components and image is also logged 30 times. At least there's 30 images. Let's see. So this is what this is what is 3D reconstructed, is it? This image. So, okay, let me try to do another example. Something like that. Structure for motion means given many overlapping 2D images from a moving camera, estimate where the camera was for each image, where scene points are in 3D. The key idea is not exactly that the system predicts from moving camera images, but that it matches the same visual features across multiple images. So a better version is it detects key points, 2D key points in each image, match key points that appear to be the same physical point across images, estimate camera poses, translation versus rotation for each image, triangulate, match 2D observations. Your reprojection error understanding is based at 3D point plus a camera pose plus camera intrinsics can be projected back into the 2D plane image when the reprojection is the distance between where the 3D point projects into the image and where the matched 2D point was actually observed. Small error means that just an estimate of a large error means something does not line up a peak in. And the reason why something like this would be necessary, important in physical AI is let's see. Peak does not remain the image function. All right, it's the clean. Yes, the clean version of your summary. Structure for motion reconstructs 3D screen structure and camera motion 2D images. It does this by matching 2D key points across images, estimating camera poses, and triangulating 3D points. Reprojection error measures, however, the estimated 3D geometry and camera pose explains the 2D. And yes, that is the motivating bridge to physics. A physical AI system needs some way to turn raw sensor streams into a usable model with camera images. Where am I? What is around me? What can I do next? Structure for motion is when classical version of the problem a moving camera sees many 2D images and from overlap/parallax or across those images, the system estimates the camera's motion through space, 3D structure of the surrounding scene, which visual features are stable enough that matters because an embodied speed is a small correction. Structure for motion itself is usually offline or batch-oriented, while a robot often needs like visual odometry, SLAM, depth estimation, where Rerun fits. Rerun does not do the construction. Rerun makes the reconstruction inspectable. It lets you line up what the camera saw, what key points features were used, where the system thinks the camera was. What 3D world it reconstructed, how confident this is why it matters. These systems fail in spatial, temporal, multimodal ways. Rerun gives you a way to see these failures instead of only reading logs. Okay. I think we should do another example. Different variety. Feel let me just $18 million data points. Hopefully it doesn't take too long. Well, 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 well. Uh, uh, yeah. This is while I was just like waiting for this to finish. I was just thinking how strange this experience is, right? Like just knowing that what I functionally speaking, I'm talking to myself, right? Like, which is something I do. I mean, it helps me think through things. But like, functionally speaking, when I'm like doing a live to an audience of one, which is me, it feels like I'm talking to myself. And I was thinking like, oh, what should I say, or like, what should I speak about, and what should I think about? I was going to say something like, oh, the World Cup is like super fun, or some of the games are very, very interesting. For example, yeah, I was just watching Saudi Arabia versus Uruguay um, in the gym, and like when Saudi Arabia scored and they were like hanging on um, until like Uruguay scored, everything is like so dramatic, right? And it is a good kind of dramatism because like sport is from the as John Oliver puts it, like football, I guess, like sports in general, if you want to be charitable, but like football really, from the things that are mundane and not important, it's the most important thing, right? Like, so, and you can certainly see that in the players and the nationalities and the games. But yeah, coming back, like, while I was just like waiting for this to finish, I was just like, oh, it feels very weird to talk about these things because it's almost like I'm talking to somebody, but there is no somebody, at least not now, right? I'm not speaking to um, anyone right now except for myself. But even that is like, it's such an interesting experience. All right, so it seems like this is done. Let me just have a look at the rerun HTML to see what it's trying to teach me. Feel a different reach of the rerun. Dense point clouds plus a moving platform trajectory over the time. Reconstructs the scene from the drone LiDAR. Demo starts with direct 3D sensors measurements and asks where was the drone when these points were acquired. What the data is LiDAR. Laser sensor emits measurements that become 3D points. In the full data set, there are millions of points acquired at the thousands of time points. At thousands of time points. Trajectory. The drone part is a series of 3D positions over the same time axis. It lets you connect it to what Rerun adds. Without Rerun, a huge .las point cloud file and a trajectory CSV. Points exist, but not how they accumulated across the spatial data. You can scrub by time. You see recent LiDAR points near the drone's current position. A visible time window shows a manageable slice of the world. LiDAR and drone share the same timeline. Timeline. Can you Right, so you have entities, you have descriptions, you have LiDAR, which is points 3D LiDAR points group by acquisition time, and then you have drone, which is the drone's position sample. 2.2 considerations. Let me just run it. Because I guess that was pretty obvious question, but so let's see. LiDAR is scanned by laser scanner. It emits laser pulse, measures the return times, and converts those into 3D points. And the data form is .las, and then the trajectory is .csv, which is measured using something like IMU, visual odometry, SLAM, LiDAR odometry, read propulsion measurement, GPS available. Right. The demo then logs LiDAR terms about RAD and curability. Yes, it's not just a video recording of the view, it's a data recording. It stores log data, structure chunks built around Rerun's entity, component, timeline. The most important pieces are entity, timeline, and components. Yes. The ECT or ETC. This means multimodal and multirate can be stored without forcing everything to one table like time, image, LiDAR. That flat table would be awkward because different streams update at different rates and have different shapes. Instead, Rerun can store chunks like LiDAR, time, points, 3D positions, drone, time, points, 3D positions, and things like that. So the clean mental model is .rad is not a movie, it is a time index, entity organized, columnar data recording, and that is why Rerun is interesting for physical AI. Physical systems naturally produce messy multimodal multirate streams and The pulse travels until it hits a surface. You have a wall, you have a floor, you have a ceiling. Then some of that light reflects back to LiDAR receiver. The sensor measures the time between pulse emitted, pulse return, because light travels at a known speed. Okay, that makes sense. Right, let me show you how it looks like. Yeah, this is what it looks like. You have the blueprint, right? And you have basically the drone, and these are the entities, right? So you have the root entity, and you have the drone, which is this red position, right? Basically, I think it's the position, and then you have the LiDAR, which is as we saw in the response from Codex, it's basically emitting laser and then like laser pulses, and then trying to see like, oh, when is it coming back to map out the space around the source. Right? Let me just have the description, which is the text. I can just turn those positions, radii, colors, it's red, and then you have the LiDAR, which is points. It's interesting. Properties. And then let me just propagate it in time, right? So this is how the drone is moving. Oh shit. So this is, I think this is before the drone starts moving, and but it's still doing the LiDAR to get a sense of how the building looks like. And now it started to fly, and then now it's flying. And this is interesting because, like, without Rerun, people would have to build out, because without LiDAR, maybe there would exist a system where this kind of mapping is done independently, and the trajectory mapping is done independently, but not on a single time continuum, and not in a way that is easily understandable, right? Like understandable and observable in that sense. The question then that I have now is the reach, like the maximum theoretical reach of if they play for data layers to be a true bet. Okay. Oh, it's a long prompt. Yeah, so this is what I was thinking, right? So basically, in my limited understanding, what Rerun has built is a way to. What Rerun has built is data infrastructures and a data language, which can be used to convert any kind of I guess input data of any multimodal and multi-rate data into those specific um, archetypes or like catalogs or type entities um, that Rerun has built for, and then use that to build what Rerun calls the Rerun. I don't know if it's like a full form, but like Rerun recording, right? Like the .rrd file, where everything about the run, basically from all these different places, that describes in its essence the same phenomena, right? Like for example, in the case of like drone um, phenomena, you have the drone flying, which is like the trajectory of the drone, and then you have the lidar data, which is describing everything around the drone, right? So uh, basically, what we know is that these two data are describing the same phenomena, and we want a way to understand it as so. And Rerun basically does that. It makes it easy for us to render different data in the same view, which is what the simulation did, which is what the recording did. And you can dissect it frame by frame, you can query it. So let's see, and this is why I asked the answer. I think so. If what they built, if what they have built is to succeed, I think the next logical step is to make it easy and efficient and effective for an AI agent to use and control. Because if AI agents are to do the main thing, which is like, okay, um, robotics, if it's for like physical AI, if an AI agent is going to be like monitoring another AI agent, you want them to know and interact and like easily break things in the recording, or like you want them to easily know from the art recordings, or like you want them to be easily you want them to be easily you want them to have a system where they can easily query like Rerun's recording to figure out whatever problem they have or whatever the question they have, right? And that would be useful because, I mean, most easily it allows for scale, and it allows for more, I guess, addressable market, and it also allows them to expand into more agentic use cases, right? Currently, it seems is a very human centric. So that's why I asked the question of like, oh, it seems to be quite human centric. Is it aimed, or is it positioned to be aimed towards AI agents? And the thing is, like, the most probably the answer is no, because I asked Codex to like just understand Rerun, and it had some hard time understanding it. So it may just be that, I mean, it's an SDK after all. So yeah. So let's see. Rerun is a human viewer first, but not human only. The stated product direction is a shared data layer for logging, queuing, transforming, visualizing, and training on multimodal physical. That makes it usable by AI agents. In principle, but I would not say Rerun is currently marketed or shared primarily as an AI agent on diagnostic substrate. The grounded Rerun is definitely solving a human cognition problem. The viewer exists because humans cannot easily inspect images, point clouds, poses, transforms, scalars, logs, and model outputs as raw files or numbers. The viewer turns those streams into synchronized visual representations. That part is explicit in the language. Physical AI teams get stuck because sensor data arrives at different rates, formats, and understanding failures requires visualizing multimodal data together in time. But the infrastructure is not just view, right? It goes road, and close log. Okay, so you give me later. Yeah, curated out of Rerun. Yeah. Okay, let's see. We are about to be done. Ooh, wow, it's late. I really thought this would be a short time, but looks like it isn't. Yes, Asian native workflow makes sense, but I would not start with the best abstract which provide ideas. Let's just split them into best build now browser agent flight recorder is the most agent native rerun project where it makes the browser agents naturally produce multimodal temporal traces, screenshots of visual clicks are spatial, DOM summaries, and actions are text. It is better than generic agent trace view as the first visual. Hmm. Tiny physical AI dataset builders. This is less flashy, but strategically best. Okay. So, tiny physical AI. Well. Okay, let's see. All right. Yeah, I think this is an interesting plan. I might work on this weekend. But yeah, I mean, I think this is about it. I think I got most of what I hoped for, which is mainly just getting a sense of like what Rerun is trying to do and like trying to understand how the code base is, right? Of course, like I didn't code anything by myself, so there's certainly a level of misunderstanding or like lack of understanding that, or like cognitive scaffolding that, or cognitive debt, right, that I have. But hopefully it is good. Yeah. All right. See you, man. Goodbye.